Hey everybody. So I've had a few different people ask questions about this graph. So I thought I would go ahead and post a video going through finding all of the pieces for this one as well. So first thing we want to find here is f of 0. So remember, this is our function notation, f of 0. All right, and so all we want to do is we want to look on our graph for where x is equal to 0 and find the corresponding y value. So if we look up there, when x is equal to 0, go up to our graph up here, and it looks to me like our y value is 5. So f of 0 would equal 5. All right, so then similarly, if we're finding f of -4, we're looking for, again, where x is equal to -4, and we want to try and find the corresponding y value. So here, when x is equal to -4, follow it down to our graph, right around there. And this one I would say is about -3.6 maybe, just kind of estimating based on that graph. So about -3.6. Okay, so in this next one, still using that function notation, but this time it's saying f of x is equal to 2, which is the same as saying y equals 2. And we want to find the x values where this happens. So I always like to solve problems like this by just drawing a horizontal line across my graph at that y equals 2 value. I'm just going to draw that horizontal line across here. All right. Then we're looking for anywhere that our graph intersects that y equals 2 line. So I'm just going to put a dot on my graph at every point where we have an intersection. Okay. So all of these points right here will be solutions to this question of where does f of x equal 2? And we're just going to have to estimate our x values the best we can. So just looking at these, I would say this is approximately -9.8 for the first one. Let's say maybe -6.5 for the second one, and -1.3 maybe for the third one, 1.2-ish for this fourth one right here. This guy looks like about 4. And then our last one out here, maybe 7.4. And I'm just estimating. If your decimals are a little bit different from mine, that's of course 100% okay, as long as you're close. Okay. All right. All right, so our next question here is asking us for the zeros of our function. So remember, zeros is just another word for x-intercepts. So we're just looking for where does our graph cross the x-axis. All right, so looking for those zeros, looks like at about -10, -6, -2, maybe 1.5, and 8. All right, so our zeros, x equals -10, -6, -2, about 1.5, and 8. All right. So all those questions are just really reading points off of a graph. Okay. Now let's get into some of the more complicated questions. So these next two, we're looking for the domain and the range. So remember, domain is the set of all x values on the graph. So basically, we're thinking we want to read our graph across from left to right, and we want to know, where does our graph start? Does it have any breaks or gaps in the middle? And where does our graph end? So I'm just going to kind of think of this as a number line down here. And let's just sort of go across. Okay. All right, so starting on the left-hand side, I can see that our graph starts right here at about -10.5-ish with an open circle. Okay, so about -10.5. with an open circle. Okay, then it's going along, everything's good, everything's fine, no breaks, no gaps, nothing weird, until we get to about x equals 2. Okay, at this point you can see that we have this gap in our graph. Okay, this is what we're going to call later a vertical asymptote in the graph. We'll get more to this in Unit 3. We'll come back around to this type of thing in graphs, but for now all you have to recognize is just that we have a break in our graph. So because we have that break right there, I'm going to put an open circle on my number line, and then I'm just going to keep on going. So again, everything's good. And then you'll see at the end here, we have that arrow, which just means it's going to keep going forever. Okay. All right, so then just putting that number line into interval notation, we can see we start at about -10.5 with an open circle. So that's going to be a parentheses on our graph. We have this break at 2. So again, those are parentheses because we're not including the 2. And then it's just going to go on to infinity. So putting that down, we would have parenthesis -10.5 to 2, okay, because we have that break in our graph at x equals 2, and then union to infinity. Okay. All right, then our range. So range, remember, is the set of all y values on our graph. So we're just going to read our graph from bottom to top. All right, so again, I'm just going to kind of think about a number line. Okay. Now here, all right, even though this one doesn't have an arrow on it, because it also doesn't have a closed circle or an open circle, we can just sort of assume that this continues, and same with this guy up here. There's no open or closed circle. We can just assume that that's an arrow. That's a safe assumption. Unless you have a clear open or closed circle at an endpoint, even if there isn't an arrow on it, it's a safe assumption, okay? All right, so because of these arrows here pointing down toward negative infinity, we can see that the range of the function, if we start from the bottom, these point down, so they start from negative infinity. Then if we look at our graph, well, just reading this from bottom to top, we can see that every y value here is accounted for on some portion of this graph. And then this arrow right here keeps pointing up toward positive infinity, so it's just going to keep going. So the range on this one is just going to be all real numbers. So remember, when you're finding the range for a function, you can't just focus on, say, one chunk of the graph, okay? This entire thing is the function, right? So even though this piece of the graph might have a maximum right here, because this piece of the graph goes up to infinity, the function as a whole goes up to infinity. Okay, so even if your function is split into different pieces like this, you're looking at the entire graph as a whole. Okay, all right, so our range on this one is going to be all real numbers, or negative infinity to positive infinity. Okay, then we are looking for our absolute maximum and our absolute minimum. So absolute maximum, remember, you're looking for the absolute highest point on the entire graph. But if we look at this, like I mentioned a second ago, we have this arrow pointing up toward positive infinity. Because we have that arrow there, that's telling us that our graph never ends, it just keeps going up and up and up and up and up, it's never going to reach a maximum point. So therefore, there is no absolute maximum. And similarly, we have these two arrows on the bottom that are pointing down toward negative infinity. So same thing, because our graph never reaches a minimum point, it just keeps going down and down and down and down forever. There is no absolute minimum either. Okay, so these absolute maximum and minimum values are typically going to correspond with what you said for your range. Your highest point is going to be the high point on your range. Your lowest point is going to be the low point on your range. And if these are infinities, there is no high and low point, so there is no absolute max or min. All right, now relative maximums and minimums, we're just looking for the tops of our peaks and the bottoms of our valleys. So let's look at our relative maximums first. So the top of any peak. So I would say right around there, right around there, and right around there, we have relative maximum values. Okay, and just do the best you can to estimate if you need to. And we're going to write these as ordered pairs, okay? There are some textbooks out there, there are some instructors out there that would just list the Y values, but I would prefer if you guys list your maximums and minimums as ordered pairs. I want to know what is the maximum and at what X value is it happening. So write it as a whole point. Okay, so our relative maximums, our first one, I would say that looks like about negative 8.5, 6.8 maybe. And again, I'm just estimating. If your decimals are a little different than mine, that's 100% understandable. All right, this next one looks like about 0.5. And then the last one, I'd say about 6.4. Okay. All right, then we also want our relative minimum values. So there we're looking for the low points, the bottoms of our valleys. So I would say right around there and right around there, we have relative minimums. Okay, and again, just estimate if need be. So that first one to me looks like x equals -4, y equals maybe -3.8. So -4, -3.8. And then the second one, I'd say 4.2. Okay, there we go. All right, the last thing we're looking for on this are the intervals of increase and decrease. So with intervals of increase and decrease, remember we're reading our graph across from left to right, and basically think if you're a little person walking along your graph, if you're hiking up a hill, you're increasing. If you're going down a hill, you're decreasing. So let me go ahead and just sketch this out. Okay. So first of all, starting over here on the left, we're going up. So we're increasing all the way up until we get to that relative maximum up there at the top. Okay. Then after we hit that maximum, we turn around and we come back down. So we're decreasing. Hit that relative minimum, turn back around again, and we're increasing. Hit that relative maximum, turn around, and we're decreasing. Okay. Then we had this break in our graph. Remember we said we had this break in our graph where our domain didn't exist at that point. So it decreases here pretty much until x equals 2. Then we jump over to this chunk of the graph, and we're still going downhill, so we're still decreasing. Then we reach that relative minimum, turn around, increase, reach our relative maximum, turn around, and decrease again. Okay. All right, so getting out a highlighter or different colored pens or something, I think can be helpful on these because you can just sort of go across from left to right and think uphill's increasing, downhill's decreasing. Now, when we list out these intervals in interval notation, it's just going to be based off of the x values, okay? So our first interval here, we're increasing from about x equals -10.5 to x equals -8.5. Okay, so -10.5 to negative 8.5. And those are both x values because this is an interval. All right, then we're decreasing from x equals negative 8.5 to x equals negative 4. So decreasing from negative 8.5 to negative 4. All right, then we are increasing from x equals negative 4 to x equals 0. And negative 4 to 0. Then we are again decreasing from x equals 0 up until we have this break in our graph at x equals 2. So 0 to 2. All right, then we jump over 2 over to this other chunk of our graph, and we're still decreasing. So from x equals 2, where we have that break, until our minimum at x equals 4, we're decreasing. So 2 to 4, we're decreasing. All right, then we're increasing again from x equals 4 to x equals 6. And then lastly, decreasing from x equals 6, and this just keeps on going to x equals positive infinity. So 6 to infinity, okay? And I just want to point out here on this last interval, remember, just like everything else, our intervals of increase and decrease are based on the x's, okay? So even though this arrow is pointing down, the important part is that it's pointing to the right because that's the direction that our x's are going. So that's why it's going to positive infinity.